Development Committee. We are trying out a slightly new format for webinars. Typically, they've been on the longer side, 30 to 45 minutes with time for questions. But we are hoping these quicker talks will be, a nice break for your day and to see, what your colleagues are working on. This is also a good opportunity if you've been thinking about presenting anything, but we're too intimidated about the longer format. We are always looking for presenters and people to share their work, so please consider sharing your work here as well. To make it even easier to present, you can also pre-record your talk and we can air it that way as well. Without further delay, though, I'd like to introduce our speaker today, Dr. Tao Tang. He is a professor of GIS and geography at the State University of New York, Buffalo State College. He has more than 20 years of work experience applying GIS and remote sensing. He teaches GIS, remote sensing, and physical geography classes. And he is also one of the members of the Professional Development Committee. So if you have any questions as he goes through, please drop them in the chat and we'll make sure he gets to see them. And now over to you, Tao.
Thank you very much, Melissa. Also, I would like to thank all the members in the Professionals Development Committee to support me to do this presentation. Yes, good morning, everybody. Basically, today I would like to report the surface moisture monitoring and mapping in Vineyard in Erie County, New York, using drones. So here worked with me, also published this paper with me, my co-authors, Michael Rodomsky. He is my former graduate student. He works at the Sony Information Technology Exchange Center, and we discussed this idea in the beginning. Also, Michael Stephan, he's a farmer and also high school teacher in the town of Eden, and he owns land and he helped us all the way along. Mary Pirelli, our GS lab manager, wherever I want somebody help me to fly drone, I couldn't find a student or something. And Mary always harassed for work with to go out to do the field data collection, and also my current graduate student Hu Tongfan, and he basically helped for the data processes, part of the data processing. Okay, so basically. In recent years, drone and UAV have been very popular for collecting the close range data in the remote sensing to many various different applications. One of the major applications with head-on development is precision farming. So precision farming not only doing the reconnaissance to try to utilize drone to find what's going on in the field, but also try to do the field dusting and pesticiding, and also some kind of help for the crop growing. So I think the UAV-based artificial intelligence and rapid GS mapping. Here I want to say, okay, the GS mapping is not like our conventional way, or we just do a very nicely laid out mapping in the end of our project. Here is basically a standard reporting form, maybe for the precision farming, and the turnover time should be very fast. As far as my understanding, this can fulfill the requirement of the farmers' management for their crops and land. Okay, here are some other researches. This is not my research. Some other publications is very hot worldwide, and people try to use NDVI, normalized difference vegetation index, which are developed in remote sensing with the satellite images, now try to fit into the drone level close range remote sensing and try to figure out what is the healthy status of the crops, different types of crops in your field, with a very, very high spatial resolution. And also we push for very, very high temporal resolution. So basically, through this study, we figure out not only we need to recognize spatial scale, but also we need to recognize temporal scale for the GS studies or the study of the geography. Okay, the objectives of this study are we first we would like to fly the UAV to collect the large footprint data, mainly on the RGB and infrared images in this experiment field grape growing during the grape growing season. So basically, we have a very large plan, a very ambitious plan, and we want to produce more monitoring results and to analyze the results and see what are the changes in growing season. So that basically is an ambitious goal. And also would like to produce high spatial resolution digital elevation models and digital mosaics to do the mapping and then and utilize the map to guide the farmers, the very detailed map, digital map to guide the farmers for their practice. At least we try to make the intelligence part to advise the farmers. So in this case, we found some difficulties. We do not even have a very suitable index to fit this type of the spatial scale and temporal scale needs for precise understanding of the temperature on the farming surface and moisture on the farming surface. So we end up try to use the current index, namely NDWI, normalized difference water index developed previously, and also TWI, topographic wetness index, to generate some kind of a surface moisture mapping index in order to fulfill this requirement. This is just the beginning of this here, and still a lot of research development need to be done. Okay, basically, what's so-called the surface moisture mapping index is a combination of the two. So our original thoughts here, and with this close range survey of the drone, and what we get here is the soil surface or crop surface moisture content. It's not solely can be identified by the reflections of the solar radiation, and could be also influenced by other factors such as the soil texture and also the micro topography, the slope in the field, and so on and so forth. That's basically also should be taken into the consideration in this process. So basically, the study area we engage is in Western New York. The Vineyard is located in the Eden Valley, Erie County, New York. The total area is 106.8 acres. Eden Valley has rich agricultural history. The farming practice can be traced back to 1801. It's traditionally is in the heart of American farming land. Of course, with development of a country this long, and also many of the farming land tend to some other uses as well. But still, up to this date, this is the heart for the agriculture productions such as dairy farm, vegetable farm, and he's actually one of our authors is own a large he farming field inherited from his ancestors, family business. This is so, and we also produce grapes for New York State wine production. So this is why we hook on with this as a starting point. So here, basically, the equipment we use here is we used both DJI Inspire Pro 1 drone, which basically this drone, the nice thing here is you can change your sensors or use a remote sensor. Fashionable term is change your sensors, and basically is change your camera. So we will be able to use the infrared camera on this drone. And also we use the DJI Phantom 3 Advanced with the color RGB images here as our data collections here. So we also use the Pix 4D capture in the field to control the drone to do intelligent fly with overlapping of the flight lines, which later on we can stitch the images together, also making the digital surface models, you name it, and we can do quite a lot of things. So the Pix 4D company and did a good job, which provide this software for the outdoor in the field management of the drones and also indoor interpolations. So here is how we plan for the field flying route here, which basically is pretty much standard, and we plan this route. Then and we ask the Pix 4D capture software to control our drone to fly the field, cover the field we need. So this is basically what we used. Here, we want to have a high frequency of the flying. However, and still, and we have this human labor situation here, which basically when you run there to do the work and need quite a lot of preparations, so on and so forth. And but when we received the data here, we download the data and we use Pixel 4D Mapper photogrammetrical software for each time to process the data. and to make the digital surface model, and also making the mosaics of the two types of the data collections here. So this is Pix4 the digital photogrammetry software, which basically from user perspective, it is easy use, user-friendly software. We teach students to do this in our remote sensing classes as well. And so basically, all these points are actually the collected frames of the images. We have thousands of the images to cover our research area or our study area. This is actually the software processing. This processing takes roughly a day or two, maybe 1 day time period. So basically, here we basically calculate the SMI surface moisture mapping index. Basically, we need to hang on with some kind of relatively index in order to figure out where it's wet and where it's dry and how dry it is. This is a relative index. Basically, is add up of the NDWIs. NDWI is managed by this simple formula. And also we use TWI, which basically is more accounting for the slope, the catchment area, and also the elevation, so on and so forth. Okay, and then we have this SMI index proposed, practiced using this combined factors. One is a reflection of the solar radiation. The other is from the local factors here. We would like to account for some textures or some, but we are not there yet. So that's basically what we formulate this. So in terms of the result here, we because we have drone operation, now we can allow us frequent data collection during the grape growing season. So the real advantage or real strength of the drone flying is not it's produce large spatial scale detailed information. I mean, you can utilize the New York State GS Clearinghouse digital also photo. That scale is also comparable with your drone fly. Maybe your drone fly is a little bit better, but that's not the key. The key is whenever we want to deploy it, we can deploy it. It is timing. It is spatial. It is a temporal resolution. It is not the spatial resolution set apart between the New York GS, New York State government nicely put together digital also photos and the drone photos. So they here and we have the time stamp much more frequent than the New York State government can afford that. So the artificial intelligence design also let us can produce the suitable data to process to get the information we would like to get in details. This is something new discovery. So original data sets collected from the field with low altitude and close range allow the quick analysis what's going on there. I think if you surveys for the precision farming work, the timing is also very important. Okay, the farmers, the practitioners, the farming company managers, they want to know, okay, what's going on now, and where is our dry place, where is our wet place, and these kind of questions can be asked very often. And where should I put my fertilizer? Okay, where should I precisely put my fertilizer? That's still the challenge to us as a GS, a remote sensing analyst. However, and we still have to endure this trouble of the labor here because Holman they all get tired, and then if you want to go there around every twice per week, and people think, are you insane? Or are you crazy? Or why you want to go there twice per week? Oh, okay. Wow, that's crazy. But if you have, you can continue to develop this, modify this here, and it can produce an automatic monitoring system. So basically, original data was made for the digital surface model here using the Pix4D mapper. So which basically this is the example here. Then we can utilize this data spatially, make the index map. Here is the index map here. Basically, this is the index map showing by date, and we did the 4 round in this study here, this here, and then this is another different time step map here. Here, basically, in general sense, we found in this particular temporal and spatial monitoring situation, we have this 4 different categories of the summary here. My time is up, and so I just go over this here. And then basically what we found here, yes, it's does show the difference. The topography, the localized conditions influence the entire spatial pattern, that spatial feature. But the rainfall patterns, climate, or the rainfall weather pattern is just the add-on to this. That's basically what we found. Okay, but in the future, and we maybe develop a more automated, streamlined indoor-outdoor process here. And finally, this is basically what we published this paper here. Questions? Thank you.
Thank you, Tao. That was great. You don't think of farming as a high-tech industry, but it certainly seems that way from your presentation. If anyone has any questions, you can type it in the chat window. I'll just give people a few minutes to type. I see all the dots moving in the chat window, but oh, here we go. From Mary Susan, was using the AI algorithm essential for being able to mosaic the UAV images?
Very good question. And UAV mosaic has already been solved by the Pix4D mapper, and also as far as a Mosaic, and produce DSM concerned, we have already reached the semi-automatic mode, which still we need to process. I think GIS analysts indoor can streamline this using the ArcGIS and also other softwares like Earth Imaging and so on and so forth. But the situation, I think the bottleneck now is the field data collection. The field data collection and could be a big hurdle. And how can you quickly turn around for the field data collection? So this is one of the major situation. Another situation is, of course, how quick you can turn around, generate the final GIS digital map presentation, quickly guide the farmers, which basically, and this is also another issue. So I think the field. So okay, now you can enjoy your fly of the UAVs. Okay, I'm a UAV specialist. Okay, you can do that. I mean, in the near future, you could. I would like to see you lose your job, and which basically we have this relatively low cost UAVs with a launch pad in the farming field, then and automatically push a button and they can fly the certain farming field. Basically, this is not. This is some kind of equipment the farmers can purchase. And that's how I feel. And also, maybe we can do the service. Yes.
See, any more questions? It looks like Mary Susan might have a follow-up. All right, let's see. We have a question from Alexander Crest, who was wondering what the relative cost of this UAV analysis method is compared with traditional soil sampling techniques.
Traditional soil sampling technique by the GS concern is not spatial, it's a point spot. Okay, you can do that, which basically, if you have equipment low or relatively reasonable, low cost, farmers can go there to test. But when farmers read, it's a 1 point. Okay, when you do the farming, I would argue this. This is a very good question, very very good question, and I would argue when you do the agricultural production, it is a spatial industry. It is not your point industry. You cannot use a few points to represent the entire space, produce your grapes or produce your corns. So what's going on here there, we do not know. So far, even up to this date, with the most advanced farming industry in the United States, the farmers still not tell, okay, where should I precisely irrigate the land? Okay, where should I put more water? Where should I put less water? No such kind of thing. They just blanket. If they feel it, it's just a blanket. Okay, and with this help, with the GIS, the remote sensing help, and they can precisely make the decision. And that's also save their money. Okay, how much fertilizer I should put into here? Why should I blanket the phosphorus in whole land? Okay, add up some of the excessive fertilizers add up in the Great Lakes. Okay, why should do that? Oh, I have to pay for it. Okay, if you can do that, but we are not there yet. Yes.
Great. And then we have
Yeah.
one other question from Mary Susan. There are usually moisture sensors in the field, or are you using that data from physical sensors in the field?
We use a physical moisture sensor as a checking because when you do the remote sensing, you need to do the ground truth checking. We do use the ground truth checking that, but the I would say the drone based based detection, remote detection will revolutionize this. And in order to find the accurate result, either you have to labor the individual person to go, or maybe even you have a robot to go around to or whatever to test thousands or maybe hundreds of the points. But this way, and we just check 2 or 3 points, and then we are all set.
Okay, it looks like we have another question from Evan. Can this sensing technique be utilized in other topography with larger vegetation, such as a forest?
Yes. Right now we are in. I mean, even for the research published, as far as my study goes, what I found, people, agricultural scientists in Spain, and they did quite a lot of studies for the trees. Some people studied the orchards, and some people studied the vineyard, like what we did, and some other people studied this, but still quite a lot of room for many different crops, particularly like maybe the cherry trees and how manage it. Of course, when you monitor the cherry trees, it is the objective is quite different than the monitoring the wheat field. Of course, this is here, and you basically all this can be developed, but we are not there yet, and we still need to generate scale agriculture usable indicators. Let's put it this way: the indicators with farmers, with the U.S. Department of Agriculture.
Okay, we have one last question. It looks like what was the spatial resolution used for this study, and how specific is microtopographic information?
This is basically we conservatively announced this is 0.5 foot, 0.5 half a foot. That's basically conservative, but we can even go closer range.
Great. Do we have any other questions? All right. It looks like that was all the questions. Thank you so much, Dr. Tang. That was a great presentation. I'm curious from the people who are still online how people feel about the shortened format. If that's better, if you prefer the longer one, and if anybody would be interested in doing a presentation for the Professional Development Committee at some point in the future.
Thank you, Melissa. Thank you, Latika, for monitoring this session as well. Thank everybody to come.
All right, I just see a few more people typing here.
Thank you, everybody, for come and cheers, enjoying your weekend.
All right. I guess we'll wrap it up there, and I will work on getting this this video on the association's YouTube channel. Thank you, everybody, for participating. And hopefully we'll see you guys next week at our webinar about the Marco Ocean Data Portal. Thanks a lot. Have a great weekend.
Thank you.